You are identifying the slope and the y-intercept of these equations. The first three are already written in slope-intercept form. To turn number 4 into slope-intercept form, we would need to divide by 2 on both sides. And that would turn it into 1/2 x plus 3 over 2. So you can identify the slope and y-intercept here. For this one, we're going to want to swap the 2x to the other side. And then we also want to divide by -1 to turn that into a positive y. So this fifth problem turns into y equals positive 2x minus 3 when you divide by -1. And then you're going to identify the slope, and y-intercept for each of these. Notice in problem 3 that the x term and the b term got swapped. So the slope is 3 and the y-intercept is 2 in this case. Go through and complete the slope and y-intercept for problems 1 through 6. 1 through 5. What do you notice about these lines? Something I notice is that they do not cross in the given diagram. They appear to be nearly parallel. If they are parallel, they will never cross. If they are slightly off from parallel, then eventually they'll cross, but it won't be in our picture or our diagram. Yesterday, or in the previous lesson, we were talking about systems of equations, and we were looking for solutions to a system. Those occurred where those points intersected, but we don't see the intersection point here. And we also don't have any numbers on our y or x-axis to help us identify the equations of these lines. For problems 1 through 4, we are going to estimate the coordinates of the points of intersection of the lines, representing the system of equations. And then we are also going to check whether our estimate is the solution to the system. So the point where it crosses in problem 1 appears to be here, which is about 8, -6. We also need to check if it is a solution. So we're going to plug it into both equations and then determine if it works in both. The y value is -6. The x value is 8, is -8 plus 2 equal to -6. Yes, so it is a solution to the first equation. Now we're going to try it in the second equation. The y value is -6. The x value is 8. 3 times 8 is 24, so it's -24 on the top. -24 divided by 2 is -12. Oh, that's a 6, not an 8. And -12 plus 6 is -6, so it also works for the second, meaning it is a solution to the system. In this problem, I don't see any point of intersection. So we're going to say there does not appear to be a point of intersection, which would mean this system, the system is the set of both equations, has no solution. you can also see here that the slopes are the same. So these lines are parallel, meaning they will never intersect. There will be no point of intersection. For these ones, we have to graph them. This has a b value of 0. So we're starting at 0, and our slope tells us to go up 2 and over 1. And then remember, we're going to draw a line through those points. For the second one, we start at positive 4 on the y-axis because that's the y-intercept. And this also has a slope of 2, so up 2 and over 1. Notice these are also parallel. They have the same slopes, so there will be no point of intersection. When we say the system, we're talking about this set of equations, which is identified by this little curly bracket over here on the left side. For this one, it also has that slope of, or that y-intercept of 0, and a slope of negative 2 this time. Since it has a 0 y-intercept, we start right here on the y-axis at 0. This negative slope tells us to go down 2 and over 1. And we'll draw a line through those points. For the other line, we are starting at positive 4 for our y-intercept, and we're going to go up 2 and over 1, since it's positive 2 for our slope. It appears that the lines cross at the point negative 1, 2. We need to verify that it is a solution to both. So in the y coordinate, we need to put a 2. And in the x place, we need to put a negative 1. Negative 2 times negative 1 is positive 2, so we know it's a solution, since 2 equals 2. For the second equation, again, replace the y with 2 and the x with negative 1. 2 times negative 1 is negative 2. And negative 2 plus 4 is positive 2. So it is also a solution to the second equation, which means this point is a solution to the system. For problems 5 through 10, determine by inspection whether the system of equations has a solution and explain how you know. So we don't actually have to figure out what point they cross at. We just have to determine if they intersect and how we know. If the equations have the same slope and different y-intercepts, they are parallel. So problem 5, parallel lines never intersect. So these have no solution. These lines, -3 and -1/3, are not the same slope. And if they are not the same slope, they are not parallel. So eventually, they will intersect. Seven, these are not in the same format. The first one is in slope-intercept form, but the second one is not. If we want to change it to slope-intercept form, we want to leave the y on the left side, but we want to move the 2x to the other side. -2x and +2x make 0, so I have y on the left. 2x and 1 are not like terms. One of them is a variable and the other is a number, so we're going to write them next to each other rather than trying to combine them. Now if we look at the slopes, they do not have the same slopes, which means they are going to intersect eventually, so it does have a solution. If we think back to previous lessons, when we had y equaling a number and x equaling a number, one of these lines was vertical and one of them was horizontal. Y equals 7 is a horizontal line, which has a slope of 0, right? You can think of it as y equals 0x plus 7. So it is a horizontal line. It has a slope of 0. But this other one, x equals 7, is a vertical line. So since we have a horizontal and a vertical line, they will eventually cross, meaning they have a solution. Neither of these are in slope-intercept form, but I can move the x to the other side. That would give me y equals -x and a +6. These can't be combined because this is a variable and this one is a number. I can also move the x from this side on this equation. That leaves me with y equals -x minus 3. You can think of this as a slope of -1, and this as a slope of -1x. So these do not have a solution, or this system, I should say, does not have a solution. The lines have the same slope and different y-intercepts, so they are parallel. If they're parallel, they never cross, so we have no point of intersection, and that point of intersection would have been a solution, but we don't have a place where they cross. X equals -2 is a line that crosses x-axis at -2, and x equals 5 is one that crosses the x-axis at +5. Those are both vertical lines, so those have the same slope and they are parallel. For problems 11 and 12, determine whether the system of equations has a solution and explain how you know. Again, we're going to change these both into slope-intercept form. This one is already in slope-intercept form with a slope of -4/5. This one I need to change into slope-intercept form by getting y by itself. 8x minus 8x is 0. The -8x and the +60 cannot be combined because one is a variable term and one is a number term. Then we need y by itself, so we're going to divide by -10 on both sides. That leaves me with y. -8 divided by -10 is 8/10, and 60 divided by -10 is -6. 8/10 can be reduced. 2 goes into both of those numbers. 2 fits into 8 4 times, and 2 fits into 10 5 times. These slopes, one of them is negative and one of them is positive, so they are different slopes. And if they have different slopes, they're heading in different directions, and eventually they will cross. So this does have a solution. For this one, neither of them are in slope-intercept form, so we'll need to move the x away from the y. That leaves us with -y equals -2x and a +7. To get it to be a y, we'll divide both sides by -1. -2 divided by -1 is +2. +7 divided by -1 is -7. For this other equation, we'll move the x to the other side. I have -4y, a -8x, and a +12. Then we will divide both sides by -4. That leaves us with y. -8 divided by -4 is +2. +12 divided by -4 is -3. These have the same slopes, so they are parallel, because they also have different y-intercepts. Parallel lines do not cross, so there is no solution. That is all for lesson 3. Check back for more